All right, this is Lee Merrick. This is for University of St. Thomas, Math 005. This is Lesson 2 for J-Term 2023. So, we're going to go ahead and talk a little bit about our different options as far as the different properties, and then I also want to cover our exponents, right, and how those work. So for the immediate, let's go through the different properties and then we can go from there. Okay, so the first property I want to talk about is the property of closure, and this is kind of a, well, of course that's right, but as far as mathematics goes, we do actually specify a whole bunch of information that most people just kind of assume, but we've actually, gone through the process of proving it at a higher level of mathematics. I'm not going to do that, but I want to make certain that everybody's aware of the idea of closure property of addition and closure property of multiplication. So closure says that if you have real numbers, and I'm going to use the symbol here in just a moment, real numbers of A and B, right? They're both members of the real numbers, and you add them together. A plus B is going to equal a number, right? That is going to also be a real number. All right, so if you have two real numbers and you add them together, you're still going to have a real number. And when you are thinking about real numbers, think about the number line, okay? That is basically what all the real numbers are, is the numbers on the number line. All right, so that's for addition. You can also have real numbers of A and B, and when you multiply A times B, you also get a real number. And that's pretty much what it says about closure. All right, so now we're going to talk about commutative property. This is one of the ones that most people are more aware of. Commutative is pretty much what it sounds like. It commutes. The numbers move around. All right, so for addition, you have the same. A plus B is going to be exactly the same as B plus A. Now that happens when we're talking in terms of adding real numbers. I do want to mention that there are, when you get further into mathematics, more advanced mathematics, commutativity may or may not still be there depending on what you're working with. Specifically, if you're working with a matrix, commutative property does not work. If you're not working with a matrix, which we are not going to do this term, you don't really need to worry about it. I just want to make certain people are aware that this is actually something that may or may not be true. All right, for multiplication, you're going to have very similar. You're going to have A times B is going to equal B times A. Those are going to give you the exact same number. All right, so that's commutative property. Associative property, we're adding, well, in addition, we're adding three numbers, and it is saying which one do you pick first. So we've got A plus B that's being added first, and then we're going to add C after that. Now, if we were to go A plus, and then I have the B plus C added first, those two are exactly the same number when you get done adding them all up. Right? You're not going to have, this one's not going to be any different than this one, even though you started here and added these two first rather than these two. Right? For multiplication, same kind of concept. If I have A times B, and then I'm multiplying that by C, that's going to be exactly the same as if I multiplied my B times C first, and then multiplied by A. That will give you the exact same result. And I'm going to go on here. Identity property. And this is, it's kind of what it sounds like. The identity property, when you have addition, if I have a number, A, and I add 0 to it, I still have A, right? Whatever number I pick, right, and put it in place of A, if I add 0 to it, I still have that original number. Okay, multiplication, same kind of idea. Instead of multiplying by 0, though, we're going to multiply by 1. So if I have A times 1, I still have A, right? That's my original value, and that did not change at all. So let's go ahead and we're going to go further here with this. We have the additive inverse. I should actually just say inverse, and then we'll talk about additive and multiplicative. So let me do that. So we have an inverse property. And this is almost the undoing of the identity property. So for addition, we're going to add the opposite value. All right? So if I have A and I add negative A, or the opposite of A, that's going to give me a 0. All right? My multiplicative inverse property so if I have A and I multiply that by the inverse, which is 1 over A, that's going to give me a 1. So as you can see, if I have A times 1, it's going to give me A. Well, if I take and divide A by A, I get a 1. So this is pretty straightforward stuff, okay? There's a little more here. It's specifically about multiplication. And you have the multiplication property of 0. And this does not work with addition. So it's the property of 0. And whatever number you pick, right, whatever number you pick for multiplying, right, our A times, and that's any number at all, and we multiply that by 0, we get 0. And again, it doesn't matter whether I go 0 times A or A times 0, that's going to get me a 0 as a result. Multiplication by negative 1. So if I have a number A, and I multiply that by a negative 1, I'm going to wind up with a negative A. All right. If I have negative 1, and I multiply that by A, right, this is effectively my commutative property in action here with respect to my A and my -1. So my -1 times A is also going to get me a -A. And I'm going to do just the distributive property, and then I'm going to end this video. So distributive property, and we normally talk about it as the distributive property, but it is the distributive property of multiplication over addition. And that means we are going to go ahead and operate so that we have a multiplication happening over some addition problem. So I've got my B plus C, and I'm multiplying that by my A. And what happens is I'm going to multiply both of those by A. All right, so I've got an A times B plus an A times C. That is the distributive property. All right.